There's two terms in probability that you're going to see a lot, and they get interchanged so much, and people get really confused between the two. So I want to just talk about them and figure out how to understand the difference between the two. And then we're going to talk about tree diagrams later. Okay, so first things first, mutually exclusive. So when I asked one of my classes what exclusive meant, they were like, well, it means you're like only dating that one person. So if you want to think of it that way. Mutually exclusive means that two events can't happen at the same time. So maybe that's why, they think of exclusive, right? You two are exclusive. You can't have girl X and girl Y at the same time. You can either have girlfriend X or you can have girlfriend Y, but you can't have girlfriend X and Y at the same time. So they are mutually exclusive. Okay, a probably less cringy example would be that you can't be a freshman and a sophomore at the same time. So being a freshman and sophomore are mutually exclusive events, meaning if one happens, the other one definitely did not happen. Rolling a dice. Rolling a 1 on a die and rolling a 6 on the die are mutually exclusive. If I roll a 1, I definitely, absolutely 100% did not roll a 6 because they cannot happen at the same time. So the probability of them happening at the same time is 0. And you can see that from the Venn diagram. They don't cross at all. So there is if it says, what's the probability of these two events happening, of A and B happening, or in this case, X and Y happening, and we know that they're mutually exclusive, then the probability is 0. So you roll a standard number cube once. E represents the event roll an even number, and T represents roll a 3 or a 5. Okay, so again, we just defined our events. We said the event E means that you rolled an even number. The event T means you rolled a 3 or a 5. And we just call them letters so that we don't have to keep saying, what is the probability that you rolled an even number? We could just say, what's the probability of E? What's the probability of T? It's just so much simpler, okay? So the first question is, what is the probability that you roll an even number or you roll a 5? Okay, so we're going to draw a Venn diagram for this one. You draw your Venn diagram, and because these are mutually exclusive, a number cannot be even and also a 3 or a 5 at the same time. So we're going to draw a Venn diagram so that they all show mutually exclusive events. Okay, so we've got this Venn diagram. E is here, T is here, and they are mutually exclusive. So what are my options? I could roll a 1, which is neither. I could roll a 2, I could roll a 3, I could roll a 4, I could roll a 5, or I could roll a 6. Okay, so those are all of the different options that I have. So what is the probability that I will roll an even number or roll a 3 or a 5? So that's the probability, and we could write this in probability terms. What is the probability of E or T, right? So either the number is a even number or it's a 3 or a 5. Well, 5 of my 6 options are in either of those circles, right? 5 of my 6 options satisfy one or the other. So the probability would be 5 out of 6. But then what's the probability of rolling an even number and a 5 or 3, right? So what's the probability of E and T? Well, we know that these are mutually exclusive events, therefore their probability is always going to be 0, because when I roll a number, it absolutely 100% cannot be even and a 5 or a 3.